Jai Hind, I am Dinanath Prasad, faculty of Electrical Engineering Department, AKGEC Engineering College. Today, I am going to discuss one of the topic that is from subject power system to basically taught in 6th semester in Electrical Engineering Department, Electrical Engineering branch, that is of code KEE 601. So in this lecture today I am going to discuss about the zero sequence diagram of transformer. So as before going to discuss about the zero sequence diagram of a transformer, we know that transformer is a static device. So as transformer is a static device, that's why in the case of transformer, the positive sequence reactance, that is, will be represented by x1, and the negative sequence reactance, that will be represented by x2, will be the leakage reactance. So we have not much worries about what is the negative sequence reactance and positive reactance. This is equivalent or equal to the leakage reactance of a transformer, because transformer is a static device. But it is more important to concern about what is the zero sequence diagram of a transformer. So basically for the three-phase case of three-phase transformer, it is basically depend how their groundings are there or their connections will be there. So based upon in the case of zero sequence, current will be following on the transformer. So we will discuss different configurations of zero sequence diagram in a case of transformer. Basically, it is very much important while studying the fault analysis in a power system. So first of all, one sequence we have to study, we have to know, or we can say the configurations of a transformer is that, which I am going to here discuss. This one. Let's suppose this is a reference point, and this is the impedance for the zero sequence transformer. Then there is a switch. So let's suppose this is switch number 1. This is switch number 2. This is switch number 3. This is switch number 4. So there is 4 switches are there. So first of all, we'll discuss one by one switch configurations. So here I will discuss the switch configuration. The switch is 1. Switch is 1 and switch 3. And switch 3 will only be closed if there are star connected with solid grounding, or there is a star connected, let's suppose, resistance grounding, or star connected reactance grounding. So these two switch number 1 and switch number 3 will only be closed. Only will close means this will be connections will be closed only if there is this 3 configurations of connections is there. If there is a star connected network with solid grounding, or there is a star connected with resistance grounding, if there is a star connected with reactance grounding or impedance grounding. So with this case, only switch number 1 and switch number 3 will be closed, otherwise this switch will be open. So what about switch number 2? This is number 1 point to be remembered always while drawing the zero sequence diagram of a transformer. Another thing is that switch number 2 and switch number 4 will only be closed if there are delta connection will be there. So this switch number 2 and switch number 4 will only close if there is a delta connected or there is a delta connections grounding or configurations is there. Otherwise, this switch number 2 and switch number 4 will open. Similar in case of switch number 1 and 3. So with the better understanding, I have discussed different configurations of transformer which is generally available, or in case this is available in the power system. First of all, I will discuss one configuration, that is, let's suppose this is 2-winding transformer having delta connected on primary side and delta connected on the secondary side. So we having the network, we having this network. We having this network. So we have assumed this is number 1, this is 3, this is 2, this is 4. So as per our study, this switch number 1 and switch number 3 will be only closed if there is a star connected, either will be any grounding. And so if we can see in this configuration, there is no star connected. So switch number 1 will always be open and switch number 4 will open. There is a no star connected network, any kind of star connected network. So the switch number 1 and 3 will be closed. And as per our knowledge, this is switch number 2 and switch number 4 will only be closed if there is a delta connected network. So in our problem, there is a delta connected in the primary side and delta connected network on the secondary side always. So the switch number 2 will close and switch number 4 will close. So if we draw after opening and closing of the switches based upon our problem, this is, let's suppose this is problem number 1 or configuration number 1, we can redraw this circuit like this. This will be open circuit. This will be open circuit. Then there is a impedance Z0. This switch will be closed, and this impedance, this number 3 will be again open, and this switch will be closed. So we will find this is the actual zero sequence diagram on the star connected network, because we know that in a delta connected network the current is always flows in the branch, not in the inside the branch, not in the line. So this is the configurations with respect to delta connections. Let's suppose we can take another example. Let this 2-winding transformer. This is delta connected, and let's suppose this is a star connected network. So we know the network of transformer is like this. So we see this is number 1, this is 4, this is number 2, this is number 3. So we can see in the primary side again there is a delta. So this switch 1 will be open and the switch number 2 will be close. But secondary side you will find there is a star connected network. There is a star connected network, but there is no interconnections. There will be no grounding. So the switch number 4 will be open and switch number 3 will be also open because there is a star connected network. So if we redraw this circuit, we will find that this will be open. There is impedance Z0. This switch will be closed and this will be open and this will be open. So we will find this type of configurations if there is a delta star connections. In a similar way, we will draw for the another case. There is a transformer, there is a delta connected, there is a star connected, but it is grounded with the impedance, some impedance that is we will call as solid grounding on the secondary side. So we know that this network, we have to remember this configurations of network like this. Okay. So we will redraw with the connections. Here the primary side there is a delta. So this switch will be closed. On the secondary side there is a star connect. There is no delta. This means this will be open, and this is star connected with solid grounding means this switch will be closed. So after redrawing, we will find that this is open, this switch will be closed, this is Z0, this will be open, this is a reference point, we always take, and this switch will be closed. So we will draw it like this. This will be open, this is Z0, and this will be the close. Because of so this will be the network we redraw for the case of delta on the primary side and a star solid grounding on the secondary side. Now we take a different case. With this extensions of this example, let's suppose number 4, there is a transformer which is connected in primary side is delta, but secondary side it is connected with this impedance. Let's suppose of impedance will be Zn. So with this case, what we know that we will find that if there is a star connected and grounded with this impedance Zn, on that case zero sequence 3 current will be flowing, that will be 3 times of zero sequence component of current. So with this that we can redraw the circuit. This is the configurations. So in this case, we have to add the there is a rule of impedance Zn, that is impedance to the grounding. So we know that in this case this switch will be closed and should be closed. So the configurations becomes here is Z0, this will be open, but there is an impedance of impedance Zn to the grounded. In this case, the zero sequence 3 times zero sequence current will be flowing in the circuit. So the impedance, one impedance will be added with the circuit, that is 3 times Zn, and this will be closed. So the circuit becomes like this. So this is the case where we can draw a circuit when there is an impedance of Zn. One more case, last case I will discuss, when in the both primary side and secondary side there is an impedance and grounded with this impedance Zn or some other impedance. So case number 5, we can see this is primary side transformer. There is a grounded with solid grounding, and in this case there is just again a star connected network which is connected with the ground. So both sides there will be a star connected network, but one side is a solid grounding and another case will be grounding with this impedance Zn. This is Zn. This is Zn. So again we draw a sequence network for transformer like this. So we know that both sides will be a star connected with grounding with some any impedance. So these two are closed, and this branches with the connected to the reference branch, reference point or neutral point, that will be open. So but in the primary side there will be solid grounding. So this is simply connected with this network. This will be open, and there is impedance which is Z0. This is again open, and this will be closed by impedance, because 3 times zero sequence current will be flowing in the circuit. So the circuit becomes this. We can write like this: Z0, 3 Zn, which is connected on both sides of the branches, and there will be no neutral connections with this. This is no any reference point connected with this network because there is a no delta connected network. One more case I will discuss when both of the side there is a connected impedance with this Zn. In the case, impedance will be Zn on the primary side as well as on the secondary side. There is connected with this impedance Zn. Again, we will do the same thing. This is the network. We see on both sides there is a grounded with this impedance Zn. So this two switches will be closed, this will be open, but on the primary side there is a impedance Z, that is impedance there is impedance Zn and the actual impedance Z0, and the impedance on the secondary side also 3Zn, and this will be the configuration because these two are open. This is open, this one is open. So there is again no connection with the neutral diagram. So for the better understanding, I will discuss one problem of the complete power system. Let's suppose this is a generator. With this impedance Zn, and in this bus number 1, this is star connected but ungrounded case. Then it connected to the transformer. Transformer primary having delta connected network, and a star will be a star grounded case. We take in the side. Let's suppose this is transmission line. This is transformer 1, this is transformer 2 case. In this case, there will be star grounded, and this is grounded with this some impedance Zn. Then there will be a load having generator. This is generator 1, let's suppose. This is generator 2. This is generator 3, and this is connected with impedance Zn, and that's it. I will discuss with this case how to draw the zero sequence for all of the power system. So while drawing this zero sequence diagram, we will take a reference point. Transformer 1, generator 1 is connected with this impedance. So we take xg1, and it is connected with this impedance Zn. So we can write as 3Zn. Then there is a G2 having only a star connected network. So on that case, we can write as xg2, but it is not connected because there is a ungrounded case. So this is not connected with this reference point. Then there is a transformer 1 having this point is open because there is a delta connected network. So delta connected series point is open, and this will be closed, and this impedance of the transformer X T1, this is transmission line 1, secondary side will be closed, and this is the impedance of the transmission line 1, and the T2 side there is a delta connected network. This is XT2. This is not connected network, and the secondary side connected with this impedance Zn. So we can add 3 Zn, and this series point is connected, and on the secondary side there is a generator, so we can represent that XG3, and this is connected with this impedance 3 Zn, so we can flow in this case 3 times 0 sequence current, that is the Zn. So this is the 0 sequence diagram. Zero sequence diagram for this power system. Thank you.